In this video, we're going to talk about assigning participants to conditions. And one of the most basic questions you can ask about this is, should every participant use every alternative? To illustrate this, we're going to walk through an example, and we're going to see the trade-offs that are intrinsic to different approaches that you can take here. In this study, we're going to compare a smart vacuum cleaner with a more traditional vacuum cleaner. As you remember from last time, one of the first questions we should ask about this are, what are the measures? Do we want something that is faster or cleaner or less fatigue, better ergonomics, lower environmental impact, portability, ease of use, fewer errors? Any of these are valid measures. You might even keep track of them all. For our example here, though, we're going to pick two. We're going to go with faster, and we're going to go with cleaner. So our manipulation is going to be vacuum type, and our measures are going to be speed and cleanliness. To help illustrate this example, I'm going to recruit the help of my graduate students and TAs. And so here they are. One thing that you can imagine is that you assign half of them to each condition. That's called a between subjects design. And so we could assign half of them to the robot interface, and we could assign half of them to the traditional interface. So Chinmay, Nicholas, and Alex get the robot, and Dan, Ranjita, and Jesse get the traditional one. And let's say, for example, that the robotic interface performs better, faster, cleaner. With only 6 people, it's hard to say whether it's because the vacuum cleaner there is better or whether the 3 people that we happen to assign to it, Chinmay, Nicholas, and Alex, were better cleaners than Dan, Jesse, and Ranjita. So the other strategy is a within subjects design, where we could have everybody use both interfaces. Which one are they going to use first? If they use the old interface first, they've gotten practice and they may be extra good or maybe tired when they get to use the new one, and vice versa. So between subjects designs have a worry about individual differences. Within subjects designs have a worry about ordering effects. Is there some way that we can get the best of both worlds? Well, how might we address these ordering effects? Well, one thing that we could do is we could take half the people and have them try one interface first, and the other half and have them try the other interface first. Counterbalancing has a couple of nice properties. For starters, you can treat it as completely a between subjects design if you look at only the first task that people do. And hopefully, the benefit that you get from practicing or the detriment of fatigue is roughly the same in both conditions, and it'll even itself out. And so counterbalancing washes out some of those concerns. There are times where this isn't the case, and that's a great time to use between subjects design. To minimize learning effects, it's probably best to make the first and second tasks different. So in this case, we might have people clean the D school as their first task and clean the Gates building as their second. This also has the added benefit of giving us some more ecological validity by trying out a couple of different environments, so we know it's not just the Gates building that's better cleaned by robots. It also has the benefit that both the D school and the Gates building are clean. How about individual differences? Should we try to balance for shirt color, hair length, gender, or whether the picture in their icon is squarish or more rectangular? It depends on whether you think it's going to make a difference in the study or whether one might plausibly believe that it would make a difference in the study. The simplest thing to do is truly random assignment. We'll talk about more sophisticated techniques in a couple of slides. Okay, so now we know a couple of ways of dealing with 2 different alternatives. But what if we have 3? With 3 alternatives, you can use something called a Latin square. I'll explain how this works with 3 conditions. It generalizes to more. In a classic Latin square design, each person is going to use all 3 conditions. You'll randomly divide your participants up into 3 different groups. The first group is going to get the first one first, the second one second, and the third one third. The second group 2, 3, 1, and the third one 3, 1, 2. So again, everybody gets all 3 conditions, but their order changes. And if you look at any particular ordering segment, so like what people see first, what people see second, what people see third, you can see that that is also evenly balanced across the three conditions. Whether you choose a between subjects approach or a within subjects approach, the most important thing to do is to make sure that the odds that any particular participant ends up in a particular condition or particular condition ordering is completely random, is even. We can illustrate this with an example. Say you wanted to find out whether people were faster typing in the morning or typing in the afternoon, and you allow people to come in whenever they want. What if people who have a preference for the morning people, are faster typers than people who have a preference for the afternoon? Your conclusion is that morning was faster, but that's not right, because it's just the morning people were faster, not that there's something about the morning. Or maybe not. You can't say. Confound. It's possible that the causal reason was population difference and not experimental manipulation. This confound is why a lot of economics is so hard. You're computing correlations, but there's no manipulation. Random assignment is tool number one in achieving an effective manipulation. So in our typing case, you would want to assign people to be in either the morning condition or in the afternoon condition. The morning and afternoon example can seem kind of stylized, but it shows up a lot in the real world. For example, if you're running a website, one easy thing that you might do is show everybody one alternative on one day and one alternative on the next. Well, there may be a difference between those days. We'll talk more about running experiments later on, but for now I wanted to point out that the key is, if you're going to do something like this, make sure that people are randomly assigned. Easiest way in most cases is a between subjects design, where you assign people as they come in to see either one interface or the other. Here's another example of the importance of random assignment. In the 1930s, some studies were run at the Western Electric factory outside Chicago called Hawthorne. And the plan was pretty simple. Find out whether changes in lighting levels affected productivity. So, experimenters came in, raised the lighting levels, productivity goes up. Then, they tried lowering the light levels. Productivity went up. Tried a whole bunch of combinations. After each intervention, productivity went up. The conclusion, of course, is that it's the act of intervening rather than the light levels itself, which was the major cause behind a productivity change. Presumably either the workers felt like people cared about them, or the excitement of the experiment, or whatever. That was the driving factor. In recent years, some economists have questioned whether, in fact, there was a Hawthorne effect at the Hawthorne plant. If you're curious, you can Google more about that. In either case, the name stuck, and it means a case where what you're seeing as your effect is a result of the intervention rather than the thing that you were trying to study. And you can avoid this with random assignment. We've talked about counterbalancing the order of conditions that participants experience. You can also counterbalance how you assign people to conditions. Say, for example, you're worried that typing speed will differentially affect something in your interface. You're building a new spreadsheet or something like that. You could use a pretest to establish typing speed ahead of time and use that to assign people to conditions. There's many techniques for doing this. The simplest way to do it is just look at high-speed typers versus low-speed typers. The key, no matter what, is that each participant has an equal chance of ending up in either condition. Let's walk through an example. If you can pre-test everyone ahead of time, one slick thing that you can do is form matched pairs. So say we get the typing speeds that we see here, and after ordering they look like this. We can group them into pairs, and then for each pair we can conceptually flip a coin about which of them is going to land in which of the two conditions. I got one of these dollar coins at a ticket machine the other day. It'll do well for flipping. So for 35 and 37, that's heads, so we'll put 35 down here in our first condition. 37 goes in the second. Then for 57 versus 59, it's tails, so 59 goes here. Third one's heads, so that gives us 61, 68. And tails. And that gives us 99 goes here, and 70 goes here. By doing this match pairs, you're balancing out the performance of people approximately in each condition. And by having some randomness in there, you're ensuring that you don't get some accidental statistical artifacts that creep in by saying, assign all your odds here and all your evens there. But say people are coming in online, so you can't pretest people before the experiment. Well, what you can do is you can pick some threshold that you think is in about the middle. So for typing, you might say 65 words a minute. And as people come in, you can check whether they're above or below that threshold and label them as high or low, fast or slow typers based on that. So 35 we would say is low, 40's low, 90's high, 68's high, and so on. And you can assign them to your two different conditions. We'll call them A and B, by high and low. So our first low person to come in, 35. Tails, so they go to B. And then to balance that out, 40 would go heads. Next time we got a pair of lows, we would flip the coin again. And we're going to do that for the highs also. So the highs come in and heads. So our first high will go to A, and our second high will go to B. You don't need to make sure that you have even numbers of high and low typers unless you're worried about that making a material difference on the outcome. In fact, if you have enough participants, you can look at this 2x2 grid and compare the outcomes of the 4 cells. What you do need to make sure is that there are the same number of fast typers of high in A and in B, and the same number of slow typers or low in A and in B. There's lots of ways that you can do this kind of counterbalancing. In general, all of them are achieving the same thing, which is try and help the law of large numbers that you get in a between-subject study work a little bit faster. Now, there's a danger of assigning people based on a pretest that I'd like to warn you about. Say we wanted a pretest for coins that were more likely to come up heads. So I have some coins here. I can flip each of these a couple of times. Heads, tails. Okay, that one's heads more. This one's really heads more. Tails. Tails. That one's tails. Heads. And tails. So we have 3 coins that had a heady tendency and 3 coins that had a taily tendency. Now we can feed them a snack, so we can get a bagel. In fact, this is the same bagel as in the last lecture, so with bagels, so it's not such a fresh bagel anymore, but nonetheless we think it'll give our coins some sustenance, so we can let them each eat some of the bagel, and we want to see whether our heady coins become more so, and whether our taily coins become more so. So we think by the natural tendency of these coins is in one direction. By feeding them, I think that may make them more so. So the question that we're going to ask is whether snacking increases the natural tendency of coins. And we can reflip all of these, and I won't inflict that on you right now. But you can try it yourself. And what you'll see, of course, is that none of these coins really had a tendency towards heads or tails. It's just that on a small number of samples, a few came out a little bit more heads, a few came out a little bit more tails, And if you flip them again, there will be no correlation between their heady tendency in the first half and their heady tendency in the second half. To make it a little more exciting than just the 6 coins that I had in my pocket, I decided to generate 30 coins in Excel, and I flipped them each 21 times. And you can see the results here of how many heads each got out of 21 tosses. I picked an odd number, so they would have to be either heady or taily on the whole. And what we can see if we rank them by number is, it turns out actually 15 of them had a head tendency, 15 had a tail, and the average of the heads is 12.9, and the average of our tail tendencies is 8.3. Now, after I feed them the snack, I can flip that again, and I've highlighted in yellow and bolded again the numbers that have a head tendency, and there's essentially no correlation between here. It does turn out that our heads our initial heads have an average of 10.7 after eating the bagel, and our initial tails have an average of 9.6. So we can see that both of these regress towards the mean. Both of these are closer towards the expected value of 10.5. We may see a perceived difference here between the 9.6 and the 10.7. In a future lecture, we'll learn how to test whether that's a real difference or whether that's a statistical mirage. So this danger of regression is very real, and it shows up all the time in statistical analyses of things like low-performing schools increasing the next year or high-performing schools decreasing. The assignment problem that results in regression to the mean is when you're making something like a dividing line and you're using the assignment so everybody who scores high goes up, everybody who scores low goes down, and then you measure their performance subsequently. If instead you use the pretest to counterbalance, like we did with the typists, so we put high and low speed typists in both conditions, then you no longer have that worry about regression to the mean. So the major question that we tackled here is, should every participant use every alternative? And what emerged was 3 major strategies. In a within subjects design, everybody tries all the options. This has big benefits in terms of recruiting participants. You get more work out of each person. And it works really well when you're not worried about learning or practice or exposure issues. Trying one version will pollute the other one. In a between subject study, each person tries one condition. This requires more people, and you may want to consider counterbalancing for fair assignment. It has the benefit, of course, that each participant is uncorrupted, and is, for this reason, is the most common technique that we see in things like web studies. And if you use a between subjects design, you can use counterbalancing to help even things out. What I've offered today is just a really high-level overview, and I've necessarily glossed over a whole bunch of important details, but I wanted to give you an initial lay of the land for running studies. If you're interested in more reading in this area, my favorite book in this area is David Martin's book, Doing Psychology Experiments. I'll see you next time.